Nearly 1 million miles from Earth, the James Webb Space Telescope, known as JWS, glides quietly through the vastness of space. Positioned far beyond our planet's atmosphere, this extraordinary observatory stands as our cosmic lookout, keeping a constant eye on the universe. Getting it to this distant location was a major achievement, made possible by years of hard work and collaboration from scientists and engineers around the world. The telescope's signature gold-plated honeycomb mirrors are the most advanced tools we've ever built for exploring the universe. Each mirror segment is precisely crafted and perfectly aligned, working together to gather the faintest glimmers of ancient light. The gold isn't just for looks, it's essential for capturing the weakest signals from the farthest corners of space. Because light takes time to reach us, looking deep into space is like peering back in time. Webb acts as a time machine, built from mirrors and light. When we use Webb to observe distant galaxies, we're seeing them as they were billions of years ago, long before our solar system even existed. It's like opening a window to the universe's earliest days. Unlike the Hubble Space Telescope, which mainly sees visible and ultraviolet light, Webb is designed to detect infrared light. This lets it spot ancient stretched-out light from the universe's very first stars and galaxies, objects that other telescopes simply can't see. Thanks to Webb's special vision, we're discovering a hidden universe full of secrets. With its infrared abilities, Webb can look right through thick clouds of cosmic dust, revealing the hidden places where stars and planets are born. These stellar nurseries, once invisible, are now in plain sight, letting us watch the birth of stars and the formation of new worlds, key moments in the life of galaxies. Every image Webb sends back is a snapshot from another era, a message from the distant past. These pictures aren't just stunning, they're records of cosmic history, stretching across billions of years, and they inspire us to imagine what else might be out there. The telescope stands as a symbol of our endless curiosity and our drive to push the limits of what's possible. It shows what we can achieve when we come together to seek knowledge and explore the unknown. And recently, Webb has truly delivered on its promise. The world watched as it revealed discoveries that challenged our understanding, opening up brand new mysteries about the universe. With every observation, Webb isn't just watching the universe, it's helping us rewrite its story. Each new discovery adds another chapter, showing us just how dynamic and surprising the cosmos can be, and making us wonder what else is waiting to be found. The universe is on the brink of revealing secrets we never imagined. Every new image and data set brings us closer to answering age-old questions about our origins, our place in the cosmos, and the mysteries that still lie ahead. This journey starts with a single, groundbreaking discovery. And with the James Webb Space Telescope, we're just at the beginning, ready for a future filled with wonder, exploration, and incredible new insights. On a quiet Tuesday in early 2025, a sense of anticipation filled the halls of the Space Telescope Science Institute. Astronomers gathered, their eyes fixed on monitors as they prepared to aim the James Webb Space Telescope at one of the most mysterious epochs in the universe's history, the cosmic dawn. This was a time just a few 100 million years after the Big Bang, when the first light began to pierce the darkness, and the universe was still young and uncharted. Their ambitious goal was to find the universe's very first stars, known as the elusive Population 3 stars. These cosmic titans were forged almost entirely from hydrogen and helium, the simplest and most abundant elements created in the Big Bang. Unlike any stars we see today, Population 3 stars were massive, brilliant, and short-lived, burning with a ferocity that shaped the cosmos. These ancient stars lived fast and died young, exploding in spectacular supernovae that seeded the cosmos with the very first heavy elements, carbon, oxygen, and iron, ingredients essential for planets, life, and everything we know. Discovering even a single Population 3 star would be the holy grail of cosmology, a breakthrough that could rewrite our understanding of how the universe evolved from darkness to light. With patience and precision, Webb stared into a deep, seemingly empty patch of sky, collecting the faintest whispers of light for hours on end, hoping to catch a glimpse of the universe's earliest moments. As the data streamed in, the screens began to fill with tiny, almost imperceptible specks, infant galaxies shining bravely from across billions of years, their light just now reaching us. The team meticulously searched for the unique spectral fingerprint of a Population 3 star, knowing that each new speck could represent a potential breakthrough, a window into the universe's first chapter. But as they sifted through the mountain of data, something wholly unexpected began to emerge. an anomaly that defied their predictions and models. It wasn't on their checklist, nor did it match any known cosmic phenomenon. Whatever it wasn't supposed to be there at all. The universe, it seemed, still held secrets waiting to be uncovered. It started with a single pixel, just one tiny, brilliant point of light, almost lost in the vast sea of data streaming in from the telescope. At first glance it seemed insignificant, an ordinary blip in the endless digital noise. Dr. Eris Thorne, a young and meticulous researcher, was the first to spot the anomaly. He noticed an outlier in the spectral data, a single, intensely bright point of light, far brighter than any nearby galaxy. It was so bright, in fact, that it immediately stood out from the rest, demanding attention. At first, Thorne suspected a glitch in the system or perhaps a stray cosmic ray that had struck the detector. He ran every diagnostic he could think of, repeating the tests over and over. But the signal persisted through every test, unwavering and consistent. This was no error, it was a real object. The data was clear, and the object's presence undeniable. Yet it made no sense. Too bright for a lone star, too compact for a galaxy. It didn't fit any known category, defying the usual classifications astronomers rely on. Thorne called over his supervisor, Dr. Lena Petrova, a seasoned astrophysicist. Together they examined the data, both seeing the same impossible light. Petrova's experience only deepened the mystery. She had never seen anything like it. Its spectrum was unlike anything predicted, an isolated object shining with the light of 1,000 suns, from an era when such things shouldn't exist. The readings defied every expectation, hinting at something truly extraordinary. The team checked for gravitational lensing, hoping a foreground object was magnifying the light. If a massive galaxy or cluster lay in front, it could explain the brightness. But there was nothing, no lens, no explanation. The space between Earth and the object was empty, offering no clues. The impossible light was shining on its own, isolated and unexplainable, as if it had appeared out of nowhere. The control room buzzed with disbelief and excitement. Scientists gathered around, voices rising in speculation and awe, as the implications began to sink in. They had stumbled onto something that defied every model, every theory they knew. The mystery deepened, and with it, the sense that they were on the verge of a discovery that could change everything we know about the universe. The object was named UDS-25-1, a technical label for a cosmic enigma. Its spectrum revealed a star made almost entirely of hydrogen and helium, confirming its ancient origin. But there was a twist. Faint traces of heavier elements like neon and oxygen appeared in the data. According to current theory, these elements shouldn't exist in such an early star. For them to be present, an entire generation of stars would have had to live and die already. Yet UDS-25-1 was supposed to be among the first. It was a paradox, primordial in age, but chemically evolved. The team ruled out chance alignments and instrumental errors. Could this be a new kind of star, unknown to science? The discovery challenged everything they thought they knew. The responsibility to understand it now rested on their shoulders. The universe had just handed them a cosmic riddle. The team's radical hypothesis, UDS-25-1 wasn't a first-generation star, but a second-generation star formed impossibly early. This would explain the heavier elements, but the timeline didn't fit. Standard models say it takes hundreds of millions of years for the first stars to form, die, and enrich the cosmos. Yet UDS-25-1 was shining just 290 million years after the Big Bang. It was like finding a fossil out of place in history. The discovery suggested the universe's first stars formed, lived, and died much faster than anyone imagined. The cosmos was in a hurry, jump-starting its own evolution. If stars could form and evolve this quickly, the ingredients for life might have appeared far earlier than we thought. The implications were staggering. The existence of UDS-25-1 forced scientists to rethink the speed limit of cosmic evolution. The universe was rewriting its own rules. News of UDS-25-1 sent shockwaves through the scientific community. Skepticism was immediate. Such a claim demanded extraordinary proof. Teams worldwide raced to observe the object and verify the data. Within weeks, independent teams in Europe and Japan confirmed the findings. The impossible star was real. Theoretical physicists scrambled to revise their models, facing a universe that behaved differently than expected. New theories emerged. Perhaps the early universe was more chaotic, or the first stars more massive and explosive than imagined. The discovery ignited a firestorm of research and debate. UDS-25-1 reminded scientists that the cosmos still holds surprises. The universe had just taught us a humbling, exhilarating new lesson. UDS-25-1 doesn't just tweak a detail, It forces a rewrite of the universe's opening chapter. The old View galaxies formed slowly, building up over billions of years. This discovery suggests the process was far faster and more efficient. If second-generation stars formed so early, galaxies were already churning out stars at a furious rate. This could explain why Webb has found massive, mature galaxies in the early universe. The rapid star cycle widens the window for life to emerge, suggesting rocky planets could have formed much earlier. The story of our own origins is tied to this ancient star. UDS 251 is a direct link to the era when the building blocks of our world were created. By studying it, we learn more about how we came to be. The universe's story is more dramatic and more surprising than we ever imagined. The discovery of UDS 251 is a testament to human curiosity and the power of exploration. The James Webb Space Telescope is not just an observatory, it's an explorer, pushing the boundaries of knowledge. This single star has launched 1,000 new questions and a new era of discovery. Webb will now hunt for more objects like UDS 251 to see if it's unique or part of a hidden population. Each new find will help refine our models and unlock deeper cosmic secrets. The journey of discovery is just beginning. The universe will always have the power to surprise and inspire us. As we look up at the night sky, we're witnessing the dawn of time itself. The most exciting chapters of the cosmic story are still ahead.